Alright, ladies and gentlemen, today is going to be a very fun day. Today you're going to learn something called Gaussian Elimination. Now, what we're going to do is take the stuff that you guys did with the matrix unit the matrix day we just spent, and we're going to kind of apply that to solve any system of equations. Now, what we're going to do is I want you guys to kind of look at what I have here about these two matrices we have. So, for example, you guys have the definition here. I'm guessing most of you have read it, but it's basically an algorithm for solving systems of linear equations, sequence of operations performed on a matrix of coefficients. So, Gaussian elimination is basically just another way of solving a system of equations. All right, it's more of what we call a logical way. Now, here's what's very important, because this is going to come into play not only with using Gaussian elimination, but how we actually look at these things on computers and or calculators. Now, starting off with, as we've already talked about before, when it comes to the matrix itself, what we have here is we have 3 rows, 4 columns as a 3 by 4 matrix. Now, with that in mind, when we are looking at these 3 by 4 matrices, first column will represent the x-coordinate. So this is in standard form for this function. So we have x, y, z. Now, this next part, if you want to, you could put that little line when we talked about the equal sign, and then you have basically your d, in this case, value. In other words, the integer is all by itself. Okay? When you look over here, we have 2 rows, 3 columns, so again a 2 by 3 matrix. 2 by 3 matrix only has 2 variables, the x and the y, equals, and whatever, in this case it would be c, is what they would call that. And again, if you want to show that area, put a line in here. Okay? Now, the whole idea of Gaussian elimination and how we look at this. I'm going to erase some of this stuff so you guys can see it. I know I'm going through a lot of stuff, but trust me, you're going to want me to go through this. When we look at this, anytime there's a 1, that means, in this case, this means 1x. If there's a 2 or 3 or 4 or whatever, that means like 3x. Anytime there's a 0, that means that the variable is not in that equation. Okay? So that is why when you look at this, you have a 1, a 0, and a 0. That means there's no y, no x, just 1x, so we get x equal to 5. And the second one, y equals -6, and then the third one, z, is equal to 12. Okay? And I'll kind of talk about how these are written here in a moment. All right? We did that a little bit yesterday. Now, here's the thing about Gaussian elimination. You are very, very lucky. We are not doing full Gaussian elimination. We are doing partial Gaussian elimination. All right? At some point you will do full, but not today. When we talk about partial Gaussian elimination for what we do, the basic idea that we want to do is we want to end up with something that looks similar to what we have here in this matrix. Now, it's not going to be exactly like that because, like I said, this is partial. What we are more worried about today, and I'll show it on both of these, is we want to see a 1, a 0, and a 0 in that first column. We want to see a 0, a 0, and a 1 in the third column. If we have that, you will be able to work what we call working backwards and be able to solve the rest of the system on your own. Over here, now there's going to be different ways we can do this, and they'll be right. That's one of the nice things about Gaussian, is there's a lot of different ways to work this. We're looking for a 1 and a 0 in the first column, and then a 0 and a 1 in the third row, or second row. Sorry, I apologize. I'm thinking of 3 by 4s. Anyway, so I'm going to go through a couple of examples. I understand that this is not going to be easy. I want you guys to ask questions, especially the next day. Okay, if you got to pause it and look back, feel free to. All right, here we go. Try to do this. I'm going to do this a little quickly, so feel free to pause. All right, starting off with, this is a system of equations. So x plus y is equal to 3, x minus y is equal to negative 1. Get a chance to write that down. Okay, and again, if you got to pause, pause. Okay, from here, we're going to write this as a matrix. So first column will be your x's, second column will be your y's, and then the third will be the numbers. So first one, we have an x in each one, so a 1 and a 1, a y, and then a negative y, so that's a 1 and a negative 1. You get the 3 and the negative 1. Okay, so here's how Gaussian kind of works. What we're going to do is we're going to show different operations. Now, the thing about Gaussian elimination is just the way to show it. It does the exact same thing as what you've been taught on how to solve a system. So, starting off with what we want, we've already looked, you already see that we have a 1 up here in that first column. Well, we wanted to have a 0 right here. Well, to be able to do that, what we're going to do is we're going to take row 1, okay, and that's this one right here, and we're going to subtract row 2 from it, or it's like multiplying by negative 1. So what we're going to do is we're going to show that. All right, off to the side, you're going to write R1 minus R2. That means row 1 minus row 2. Now, here's the answer to that response. Now, let me just explain why. When we look at this, all of these right here are going to change. If we are going to take the opposite of row 2, that means all of these are going to become the opposite sign. Well, that'll become a negative 1, that'll become a positive 1, that'll become a positive 1. Now, what actually happens is this right here. Essentially, you end up with x minus x, which gives you 0x, y plus y, which is 2y, and 3 plus 1, which is 4. Now, there's going to be a lot of questions here. I didn't do anything to the first row, correct? I'm not supposed to. What we did is we leave in the first row alone because it already has the 1 in the first column that we want. When we do this operation, we are only changing the second row. You leave the first row alone. Okay? So, I like to sometimes write the system portion over here to get my values in here. You don't have to do that, but I'm going to tell you these will get complicated after a while. All right. Next step. We said we want to get a 1 right here in the second column, second row. Well, to get that, well, what would you have to multiply 2 by to get 1? Well, you'd multiply by 1/2. Now, as you can see here, we're not doing anything to row 1. Row 1 is going to stay the same. So row 1 is still going to be the 1, 1, 3. But the second row, we're going to multiply the 2 times 1/2, the 4 by 1/2. And essentially, that's what's happening. Okay? So, at this point, you've actually done all the Gaussian portion of this that you need to do. Once you have this, you now know what y is, because this is the x column, that's the y column. Since you have a 1y, you have y is equal to 2. All right, so once you have that, and you know what y is, we can now plug that back into the original equations, and it does not matter which one, all right, either one, and you're going to solve for x. So that's this portion over here. So from here, you're going to do, I use the first equation, so you've got x plus 2 now, is equal to 3, add negative 2, you get x equal to 1. So the solution is 1, 2. All right, so yes, I understand that was way more complicated than what you've already learned. That is not the idea of Gaussian elimination, all right? It's just another way of solving this. This is going to give you guys things dealing with different types of logics that you're going to be seeing in different programming, things like that. All right, and matrices are going to be a big portion of that. So we're just kind of getting used to it right now. Okay? All right, let's go on to the next one. Again, if you got to pause, pause. What this is this is going to give you kind of what I would call, I wouldn't say a cheat sheet, but give you an idea of what you're going to look for depending on what you're trying to do. So you might want to write this down. So pause it if you need to. When you have a number that you need to make 0, you're going to have the opposite, all right, by column multiples, okay? So that's going to be a big thing for you guys, all right? You're going to be adding or subtracting there, okay? That's going to be important. To make something 0, you're either adding or subtracting, or adding the opposite, all right? You'll kind of see how that works here in a minute. When you have to make a number 1, in other words, you have like a 2 or a 5 or something, you have to make it just a 1 in there. You're going to be multiplying the reciprocal of what's ever in that column and or row, okay? All right, so keep those in mind. If you learn those 2 things, there's a couple other little things in here we've got, but if you learn those 2 and you get the idea, this won't be as bad. All right, so here we go. Now this one I'm going a little slow on, all right, just to kind of give you the idea. So here's a typical problem. And again, this is just a 2 by 3 matrix, 2 rows, 3 columns, okay? So you need to change this first to a matrix. So here we go. First row, 8, -7, -6. Second row, -4, the 1 for the 1y, and then the 3. Okay, so now I'm going to do this a little slowly. There's a way to do this slightly quicker, and you guys will pick up on it, and hopefully you'll get the idea. Now, starting off with, when I look at this, one of the things I'm going to do right now is I'm going to, in this case, I want to make this a -8. You'll see why here in a moment, okay? Making this a 1 right now would actually stink. I'll explain why in a little bit. I'm going to make this a -8. The reason why I'm making a -8, you'll see why here in a second. So here we go. So if I multiply the second row by 2, right, I have now made this one a -8. Now watch what happens here. Okay? I'm going to try to make this, and you'll see why here in a moment. I'm going to try to make that 0. That's going to be important for us. To make that 0, all I'm going to do is add row 1 and row 2 together. Now, here's the key. This is important. The second number in this little sentence here is the row that you're changing. Okay? I'm not changing row 1, only row 2. So the first row is still going to be 8, -7, -6. But now, if I go about this, if I add these together, 8 minus 8 is 0, -7 plus 2 is -5, -6 plus 6 is 0. Okay? Now, from here, what I want to do, this is going to be important, I'm going to make this a 1. When we talked about making something 1, you're going to multiply by its reciprocal. So the reciprocal of -5 is -1/5. So with that in mind, with that -1/5, I'm going to multiply only the second row. The first row is going to stay the same. So repeated this first row, and now -1/5 times -5 is a 1. -1/5 times 0 is still 0. So now if you notice something here, you have y is equal to 0. Okay? With that in mind, we're going to work backwards. So what I'm going to do is plug in 0 for y into the first equation. And I get 8x at this point is equal to -6. And then x is equal to -3/4. Okay? Alright. Again, if you got to pause, pause. I'm going to keep going. Alright, next one. Again, I'm doing another 2 by 3. Trust me, you're going to want me to do more 2 by 3s. First and foremost, write it down. Pause if you need. We're going to change this to a matrix. Okay? Now, and again, it's up to you, but I saw a lot of people are usually a big fan of this line right here, so they know the difference between where the variables are and where the number is. Okay? All right. So, from here, something we're going to do, and this is up to you on how you like to do this, but I want to show you something we're going to do in this case. When you look at this, making this 1 right here, this 11, this negative 11, 1, it's going to be hard because you're multiplying by negative 1/11. These numbers right here are going to be ugly. Ugly, ugly, ugly. So there's another rule that we have. There's the possibility of something you can do. The nice thing about a system is since it's working together, they can move spots. So what I can do, and what this is called, you have this R1 with these two arrows like this to the R2, that means you're switching rows. So we're going to turn these two rows around. I'm going to write the negative 10, the negative 10, and the 20 on top. So this is just a row switch. Okay. After this row switch, what we're going to do is now I want to make that 1. So if I'm going to make that a 1, right, we talked about multiplying by its reciprocal. Well, the reciprocal is going to be negative 1/10. Okay, do that. You're going to get something that looks like this. Again, I'm only changing row 1, not row 2. And essentially, like in system, it would have looked like this. Okay, so I multiplied everything there by negative 10. All right, so from there, with that in mind, I need to make that 0. To make something 0, you're going to multiply, you're going to add the two rows together with common multiples. Well, the common multiple between 1 and negative 11 is going to be 11. Okay, so to make that 1/11, you're going to multiply it times 11. So row 11 times row 1 plus row 2 will give me a 0 right here. Okay, now here's the actual answer to that. But let me show you how it worked. I like doing this over here on the side. It's up to you whether you want to do it, but it helps me out. I actually take row 1 and I multiply it out. So I get the 11x, the 11y, and the negative 22. Here's row 2, and then I actually go through and add. So when I do that, this is what I'm putting in here. Okay, again, did I change row 1? No, because the only one you're changing is the second one in this order. Okay, row 1 is staying the same because you want to keep this as a 1. Okay, so next part. Next part is, that's 7. You want that to be a 1. We talked about what to make something a 1, you multiply by its reciprocal. That's this right here. The reciprocal of 7 is 1/7. And we're only changing row 2. Multiply everything by 1/7. Here we go. There's your answer. So now we have y is equal to 2. Plug this back in. Now I plug this. Now what I did, and this is really up to you, is I went in and I took something a little bit easier. And I took this y, I plugged it into here. You don't have to do that. You can actually plug that into one of these two original equations. If I wrote negative, I'll do the 10. I like the 10 better. Negative 10 minus negative 10 times 2 is equal to 20. I bet you still are solving it and get the same answer. Okay, which will be x is equal to negative 4. Sorry, I forgot the 10x. I'm sorry, guys. Negative 10x. If you solve that, I bet you still get negative 4. Okay? So the answer to this problem is going to be negative 4, 2. All right. So those were 2 by 3 matrices, and we solved for 2 variables. This is the fun one. All right. So if you got to pause during this one, feel free to write this problem down. Once you've got this problem down, we need to write a matrix. So writing a matrix for this one, 3 rows, 4 columns, a 3 by 4 matrix. Okay, so you got the negative 1, the negative 5, the negative 5, and the 2. The 4, the negative 5, the 4, and the 19 for the second row, and so on and so forth. Okay? All right. X, Y, and Z. All right, so for this one, we're going to use something we've already seen before, but if you notice up here, that is not a 1. Now, you have choices here. That's the nice thing about Gaussian. I'm going to show you one way to do this, but there's actually infinite number of ways of doing this problem. You could just multiply everything in that first row by negative 1, and there's nothing wrong with that. I'm not going to do that. What I'm going to do is, since I already see in the first column there is a 1, I'm going to do a row swap. So I'm going to swap row 1 and row 3. So I'm basically going to switch these two. Okay? Alright. There we go. So I switched the two rows. So I've already got my 1 up there. Switch the rows. One of the things I want to do is I want to try to make some of these 0. Now, this row, we got a 1 and we need these two 0. Now there's different ways of doing this. What I'm going to do is I'm going to make the third row 0 first. The only reason is because of how easy it is. If you notice, row 1 and row 3 already have opposite signs. So if I just add those two together, now again, remember, I'm only changing row 3, not row 1. Okay? So if I add them, and this is the way it looks when you add them, x and negative x, that gives you what? I like to do it this way, 0. 5 minus 5, so that's 0 watt. And then negative z and negative 5 gives you negative 6, and then we end up with a negative 18. So we get a 0, 0, a negative 6, and a negative 18. That is what's going in here. Okay. Now, the reason why that was nice is, hey, look what happened. These two have already become 0. Now, there are different ways of doing this, and again, we can get making that a 0 first, but what I'm going to do is, since I'm already kind of on a roll right here, I know I need to make this 1. So I'm going to do it right now. And again, how to make something 1? Multiply by its reciprocal. So the reciprocal is negative 6 to negative 1/6, which is what I would do with this. If I did this, I would end up with just a 1 and a 3. Okay? So at this point, again, with our columns, since that's the third column, that is representing z. So z is going to equal 3. Now, that's wonderful and everything right now, but we have an issue. We still have this. We talked about this being a 0. We need to make that 0. Okay, so we're going to do that on the next page. Alright, so here we go. So that's what we just had. To make that 0, we have to, again, add by common multiples. And again, we're only changing row 2, not row 1. So if I'm going to change row 2, that's what's coming second. Common multiples would be 4. So we got to make that 1, we got to make it a negative 4. So it's multiplying by negative 4. And again, if I multiply row 1 by negative 4, it looks like this. Okay? This is what it looks like. And what I like to do here is I actually like to go through and do the addition or subtraction. Okay? Okay. Now, the reason why I like to do that is because now I know exactly what I'm putting in the row 2. I'm not changing row 1, I'm not changing row 3. I'm only changing row 2. Okay? With that done, you have done everything you need for a 3 by 4 matrix. Column 1 has a 1, 0, 0. Row 3 has a 0, 0, 1, and then the answer. And you already know that z is 3. So guess what? We're going to take that and we're going to plug it into this right here. Alright, so from here, since we know z is a 3, you're going to plug in negative 25y plus 8 times 3 equals 99, which is obviously 8 times 3 is 24. Add negative 24 to both sides. Now we have negative 25y is equal to 75. Divided by negative 25, you get y is equal to negative 3. So at this point, you know that y is negative 3. You know that z is 3. You need one more. Now, again, whichever one you choose is up to you. But I chose the first row. So x is equal to 5 times, we know what z is, or y is, it's negative 3. And then minus z, which is negative 3, or plus z, which is negative 3, and then equals negative 20. Combine those. 5 times negative 3 is negative 15, minus 3 is negative 18. Add 18 to both sides, you get x is equal to negative 2. So there's your answer. Alright. I know that was long-winded. I know that took a while. But hey, this isn't going to be easy. This is why I want you guys to come to class ready to ask questions. I'm going to give you guys about 4 examples tomorrow to work in class. Please feel free while you're working at it. If there's something you're like, I have no clue what's going on, let me know, because this doesn't get easier. Okay, so I need to make sure we get this on the first day. All right, guys, enjoy your evening. Bye.